Let us understand about the Zener diode as voltage regulator or voltage stabilizer. Zener diodes can be used as a voltage regulator to provide constant voltage. Figure shows the Zener diode connected reversely across the resistor load RL through which constant output voltage is obtained. Here, the series resistance Rs is used to absorb the output voltage fluctuations so as to maintain constant voltage across the load. It is important to note that when we connect 6.1 volts 1 watt Zener diode across the load resistor RL and the applied voltage is 0.1 volts to 6.1 volts, the output voltage keeps varying until 6.1 volts. However, when the input voltage above 6.1 volts, the voltage remains constant, which will be equal to Zener breakdown voltage Vz. That is, in this case, output voltage will be 6.1 volts itself, as the Zener is in the breakdown region. When the circuit is properly designed, the load voltage Vout remains essentially constant, which is equal to Vz, even though the input voltage Vin and load resistance RL may vary over a wide range. Now let us see some of the conditions, that is when input voltage increases or the load resistance varies. Condition number 1. Suppose the input voltage increases, the line current also increases. In this condition, the Zener diode takes the increased current through it and the excess voltage drops across the series resistance Rs, and hence the load current IL remains constant. As a result, the output voltage across the load RL remains constant. Condition number 2. Now suppose the input voltage is constant but load resistance RL decreases. This will cause an increase in the load current IL. The extra current is taken by the Zener diode and hence the current through the load resistor RL will be constant. As a result, the output voltage across the RL remains constant. Condition number 3. Now suppose the input voltage is constant but load resistance RL increases. This will cause a decrease in the load current IL. The additional current is supplied by the Zener diode and hence the current through the load resistor RL will be constant. As a result, the output voltage across the load RL remains constant. From this, the Zener diode can be used as a voltage regulator. It means that the circuit provides the output voltage constant irrespective of the input voltage variations or load current fluctuations. The following points are worth noting regarding the Zener diode, which acts as a voltage regulator. The voltage drop across R can be calculated using formula R is equal to Vin minus Vout, and the current through R I can be calculated with the sum of Zener current Iz plus load current IL. Applying Ohm's law, we have R is equal to Vin minus Vout divided by Iz plus IL. Applications of Zener diode. It can be used as a voltage regulator. It can be used as a limiter in wave shaping circuits. Zener diodes can be used as a fixed reference voltage in transistor biasing circuits. It can also be used for meter protection against damage from accidental overvoltage. Finally, it can be used as a fixed reference voltage in a network for calibrating voltmeters.